I'm going to do the SAP modeler on the text file bank March 26, and I placed it in my download file so that I can easily access it. So I go to modeler, go to create, and then this is my folder, and I browse. So this is the file, and if you load it in the Blackboard and open it, then it opens up in an HTML for environment. So it's better to keep it separate. Otherwise, you'll have to copy, paste, and make that. So we do next, and very important, we click on analyze. Otherwise, it won't accept the next. So this is a bank doing campaign in which they sell various products, and they want to predict which customer is likely to accept. And so the kind of data they have is some demographic data and some behavioral data, that there have been other campaigns before, and whether the person in other campaigns had previously accepted or rejected. And then these are the kinds of data elements which are there. And they want to predict. So the y is the value 1 or 0 that they want to predict given the population. So it already selects. I mean, that's how the data is put in the CSV file, that the y is the last one. And then we do next. And very important, we check this as the compute decision tree. And then we do generate. So this is the kind of the model overview. It says predictive power is 0.76. That is, this is the equivalent of the R square in a multiple regression. That is the all the factors that decides whether a person would accept the next campaign. I mean, go through it, and so that is 76% of those factors are being accounted for this model. And prediction confidence means, if I repeat this 100 times, this whole exercise, then 94, 95 times I'll get a value very close to this 0.76. So that is kind of a robust number. That's what it says. Go to next. And then you can look at the contribution by variables. So it says, the duration that the guy has been with you, earlier time the guy has accepted, the month this is being conducted, the balance amount of money. So this is the again, just like R square, you have the multiple regression, you have different contribution by different variables. And in some sense, this is kind of RFM in marketing, recency, how recently you have been dealing with us. F is frequency, M is the monetary value. So this is the kind, I mean, has got that same kind of a flavor. And so that is the value contribution by different variables. So in your classification, then this is the confusion matrix. So it takes a little bit of getting used to it. So the good values are yes and yes. So it is true yes and it predicted yes. Similarly, true no, predicted no. So in some sense, 5.85 and 83, 88, 89% of the time they got it right out of some 12, 13. So it seems like a pretty good number. But then it depends on what the application is. If it is marketing, it doesn't that much matter, the false positives. So these are the false positives. Somebody is actually no, but I'm predicting to be yes. This is a false negative. But you can see that if somebody is yes, you know then only half of them I'm getting right. So if it is a disease and you have the virus and only half of them I catch, obviously our system wouldn't work at Bryant. So it depends on what kind of application and to what your tolerance level is about false positives and false negatives. In marketing, if it is a false positive, well, you send an email or some brochure to somebody who isn't likely to buy, and false negative means you missed out a possible sale, but then these are not a life and death decision. So this is a very important matrix about the power of the classification. And then this is a decision tree. So you can go and do display settings, and maybe the horizontal is more readable. I don't know. So the decision tree is that the system is going to show, the first variable it picked up, the duration is the most important variable, and then it gives you the choice how you want to expand it. You know, it says that given duration, this is the percentage of people who are of that particular limit, 184 to 247, uh, who are likely to, who did, agree to, are likely to agree. So positive target. So uh, 321 to 432, these are the one of the high values. And then you can expand this decision tree. So you can pick up next, say, as the p outcome, the second more important one. So given this, you want to target further, then it says of this 0.74%, of this 1.5, 1.3, all this is valuation. So 131 is 140, 140 plus 807 is 947. So that is how it is then splitting it up. So, I can then go further and go maybe balance as the next one. So that is how I end up with a very large decision tree. And, this is a little difficult to read here. And the decision tree is how eventually the system works. It follows the tree pattern. It picks up the duration, then it sees which which link you will go, given the duration, what p outcome will you go, giving the p outcome, what other variables you will go. And then and actually in capital one, I had a friend who was developing, who is who do develop these decision trees for uh, credit cards for businesses, and they have a very booming business in Mexico. And the banking thing is not very well developed in Mexico, so even businesses who are doing pretty good, by volume, they also literally take loans from credit card companies like Capital One. And so as these requests come in, the Capital One system approves, disapproves, or it fixes a interest rate. So you are in, say, metal fabrication, and you get a request that you want to buy a metal fabrication equipment. They might say, okay, on your average we charge you 7%. This is very much in line with your business, so we'll charge you 6%. But then a request comes in for something that is something you don't do, maybe inspection, and so they will say, wow, the system will catch and say this is slightly out of their field of expertise. And for an X-ray equipment, they might say, well, we're going to charge you 11%. And so what they do is they convert these decision tree into a very readable set of rules, and these rules are periodically put up to the managers. And so if a customer is complaining that that you are charging me too much, or or that they find that the number of people who are getting delayed in payment is getting high, then they look at these rules and they start, tightening these rules. And these rules are written in a very readable way, you know. So the managers can say, okay, maybe we get loose on this particular factor, and maybe we tighten up on this factor, and so on. So the rules are all the time being adjusted by the managers, depending on how the classification is working and what their response is from the customer. So this is a kind of a continuous exercise that their loan managers are doing, given this automated classification system. And so the model overview is what we saw first, and these are some category significance. That is, if you think that uh, you know duration that you've been with us is the most important one, then how much does it contribute when you are between these variables. So again, this is a more detailed contribution of variable by values. And so that is the modular exercise as on the SAP model.